The next topic we are going to see is equipotential surface. Okay, so how your potential is equally placed in the surface. This means here. So here we are going to place electric potential same for all the points in the surface. Okay, that will be called as an equipotential surface. Okay, look at the diagram. Here they given the three-dimensional view for equipotential surface. So here equally with the same angle they have given the electric potential. Okay. Next we are going to see electric dipole. Dipole. So here 2 point charges going to act with same or equal and opposite point of charges. Okay, which will be separated by a small distance. Okay, so one pole will be positive and another pole will be negative. This happens by the color red and green. Okay, so this will be called as the electric dipole. Then expression for electric dipole moment is given here. Here you consider dipole moment is the measure of strength of the electric dipole. Okay. Here it is denoted by P vector. So P vector is nothing but Q into 2A, where Q is nothing but magnitude of two charges. A is distance between the two charges, plus Q and minus Q. Okay, so Q is the magnitude of two charges. So your electric dipole moment P vector equal to Q into 2A. Next, we are going to see here electric flux. Okay, so electric flux over an area in an electric field represent the total number of fields crossing this area is said to be electric flux. It is represented by the symbol phi. Okay, phi equal to integral of e cos theta dA. Simply you can write it as the integral EA into cos theta. See the figure. E is nothing but electric field. A is surface area. So in between these two, you will be having the angle theta. So that is represented in the cos theta. In this equation, cos theta. So EA into cos theta will give the flux phi. So we can say deeply about the electric flux. So in 1837, Michael Faraday performed the experiment on electric field. He showed that the electric field around a charge can be imagined in terms of presence of the lines of force around it. Okay, so that will be a point of charge. So from that, you will be exhibiting some force due to some other charges present nearby that point charge. Okay, so that a line of force. Okay, the presence of line of force in a point charge may be many number. Okay, many fixed number of electric lines of force will be there. That bunch or closed area will be called as a tube of flux. Okay, so the total number of tube of flux in any particular electric field is called as electric flux. So electric flux is nothing but the total number of lines of force in any particular electric field is said to be electric flux. Okay. So last year பார்த்தீங்கன்னா point charge பார்த்தோம். Point charge due to the force occurring in point charge due to another point charge. இதுதான் நம்ம பார்த்தோம். அடுத்தது என்ன பார்த்தோம்? Electric field intensity, that is the force which is existing in the point charge due to some other point charge will have some intensity in electric field that will be called as the electric field intensity. So that force of line will be having in few area of electric field. Okay, so that total number of lines of force in that particular electric field together will be called as the electric flux. Okay, so ஒரு லைன்ல அதோட இன்டென்சிட்டியை டிட்டர்மைன் பண்றது எலக்ட்ரிக் ஃபீல்ட் இன்டென்சிட்டி. இதே வந்து more number of lines. Okay, total number of lines present in that particular electric field area. Okay, it's said to be electric flux. That symbol is represented by psi. Okay, so unit of electric flux will be coulomb. Now we are going to see the flux line property. So first property, the flux line. See, consider this is 1 point charge. Another 1 point charge is minus q. Okay, plus q and minus q. So in the force occurring in positive charge to the terminating charge, that is minus q. Okay, this source charge is the terminating charge. Okay, consider this is a source charge, this is terminating charge. Okay, so the flux line, the force of line, the line of force. Okay, that will be the total number of line of force will be together called as a flux. Okay, so the flux line, which is starting from the positive charge and terminating on the negative charge, is shown in the figure. First figure, and then in second figure you can see if the negative charge is absent. Okay, for negative charge absent, you are having only the positive charge. And what will be happen then? The flux line will terminate at infinity. Okay, there will not be any distance value given there because due to the absence of negative charge. So negative charge will be 0 here, so that it will be ending the flux lines at infinity. Okay, so instead if you are having absence of positive charge, only negative charge is present, then what will happen? The flux line terminates at negative charge from infinity. Infinity will start at negative charge la end aayidum. Okay, that is the figure given here from source line patina infinity, but ending at negative charge. Directions vary. இப்படி வருது இல்லையா, இதுதான் வந்து உன்னோட flux line ஓட movement. Okay, direction as well as movement. இங்க பாத்தீங்கன்னா பாசிட்டிவ் சார்ஜ்ல ஆரம்பிச்சு இன்ஃபினிட்டில போகுது, இங்க வந்து இன்ஃபினிட்டில ஆரம்பிச்சு நெகட்டிவ் சார்ஜ்ல டெர்மினேட் ஆகுது. ஓகே, then third property, 1 minute. Okay. Third property is there are more number of lines, that is crowding of lines if electric field is stronger. Okay. So if there is a strong electric field, the number of lines will be heavy. Okay, crowded. And then fourth property, these lines are parallel and never cross each other. So parallel lines of flux will be available, but it will not cross to each other. Okay. And fifth property, the lines are independent of the medium in which charges are placed. So the lines of force will be independent to each other as well as the medium. So here, even though the charge will be placed, then the lines always enter or leave the charged surface normally. So positive charge la start aagachuna, it will be ended with a negative charge. Okay, if there is no any other charge, then it will go as usual. Okay, the line of flux will continue to move. Okay. Then if the charge on your body is plus or minus q coulomb, then the total number of lines originating or terminating on it is also Q. Okay. But the total number of lines is nothing but a flux. Okay. So line of force, single line that will be called as a line of force. So if the total number of lines that will be called simply called as a flux. It is represented by psi equal to Q coulombs. Okay. Numerically we can represent it like this. So the electric flux is also called as displacement flux. So flux is normally a scalar field. Okay. So now we are going to determine the flux in the vector field. Okay. That will be called as a electric flux density. Okay. In vector quantity, we are going to determine the electric flux as the electric flux density. So now you consider 2-point charges. Okay. See, given in the diagram, plus Q minus Q. Okay. The flux line which is originating from positive charge plus Q and terminating at negative charge minus Q. Okay, see in the diagram. So you consider unit surface area. Okay, so unit surface area. Here the number of flux lines are passing this surface area is given represented in the diagram. So unit surface area, na, you are going to take a small unit or one surface area. So in that you are going to assume the flux lines passing through it. So the net flux passing through the unit surface area is called the electric flux density. It is denoted as d vector. So it has a specific direction which is normal to the surface area under consideration. So here we are going to consider a sphere. Okay, spherical shape we are going to consider where the charge cube going to be placed. In that no charges will be present around that spherical area. See here the total flux distributing around the charge will be considered as a Q. Okay, psi equal to Q. So this flux distributes uniformly over the surface of the area. So the spherical area we are going to consider one charge that is named as Q, which will be placed at the center. So that will be equal going to distribute the flux. Okay, the total flux is represented by psi. Adoda surface area, spherical area S. Okay. So அப்ப electric flux density எப்படி determine பண்ணுவேன்னா நான் மேலேயே சொல்லியிருக்கேன் electric flux density is denoted as d vector. So d vector equal to psi by s in magnitude. Magnitude represent பண்ணினா vector வராது, psi vector s vector வராது. So magnitude represent பண்றப்ப just you will be writing as a psi and s. Okay. This will be called as a displacement flux density or displacement density, or simply we can say it as a electric flux density. Now we are going to represent the vector form of electric flux density. In above equation they represented the magnitude value of density. Now we are going to see the density in vector form. Okay, that means you will be having the d vector. Okay, in the symbol la da nee represent பண்ணுவ. Again, to consider the flux distribution due to a certain charge in the free space. So here you consider a small area, that is differential surface area ds at point P. The flux crossing that differential area will be d psi. Okay. The flux line இருக்குலையா இத cross பண்ணதுலயே அந்த spherical area அத வந்து d psi னு வெச்சுக்கோ. So the direction of d vector is same as that of the direction of flux line. இப்ப d vector இருக்குலையா அதுவும் பாத்தீங்கன்னா இந்த flux lineம் பாத்தீங்கன்னா same parallel to each other தான் இருக்கும், ஒரே direction தான் இருக்கும். Okay, so the differential area ds and flux line, that is d psi, are at right angles to each other at point P. இப்ப பாத்தீங்கன்னா surface area இப்படி இருக்கும். Okay, flux lines pathina in the angle irukku. So you can consider that both the surface area and flux line are perpendicular to each other. Okay. at point P. Hence, the direction of D vector is also normal to the surface area and in the direction of unit vector AN. So, unit vector and the directional D vector same direction which will be normal to the surface area. Near point P, all the lines of flux, that is D side, flux in the lines having direction of that unit vector as the differential area is very small. So, we select the area when the surface area when the smaller you can see that all the lines of flux as well as your unit vector will be very close to each other. Okay, will be looking similar. Hence, the flux density at the point P can be represented in the vector form as D vector equal to D psi by ds. Okay, when a magnitude D equal to psi by s. They want the D vector change in flux line as well as change in area will give the flux density in the vector form into unit vector. You will be representing the direction. In a vector and the unit vector which will represent the direction. Then D vector due to a point charge Q. So D vector is the electric flux density. Okay, due to point charge Q. So Q is the center of your spherical sphere. Okay, so here the sphere, you imagine that the center of Q point charge radius is R. Okay, so your plus Q charge is placed at the center of your sphere and then radius of it is R. So the flux line which is originating from point charge plus Q are directed radially outward. Okay, so outward in all the direction it's going to send. Okay, or directed. Okay, so the magnitude of flux density at any point on the surface is going to be given as modulus of D vector equal to total flux psi divided by total surface area S. Okay, so D is nothing but psi by S. இதே any point in the surface area calculate பண்ணனும்னா you have to consider total flux divided by total area. ஒரு particular point na அந்த particular area flux அந்த particular area மட்டும் எடுத்தா போதும். But எந்த பாயிண்ட்னே தெரியாம whole area the entire ஏரியாவுல ஏதோ ஒரு பாயிண்ட்ல கால்குலேட் பண்ணனும்னா you have to consider total flux as well as total surface area. Okay, so total flux is represented by psi which can be written as Q. Okay, and then total surface area வந்து எப்படி எழுதலாம்னா sphere தானே, அப்ப surface area can be represented mathematically as 4 pi r square. So just you replace the value of psi and s here. Okay, அப்ப என்ன ஆகும் Q by psi க்கு பதிலா Q divided by 4 pi r square. This will give the vector D vector at any point. Okay, in the sphere. So thus you can write the electric flux density at a point which is at a distance of r from the point charge Q. இப்போ நான் என்ன பண்ண போறேன், I'm going to select the point, that is radius distance r. I'm going to select so that I'm going to replace the value of r at the point charge Q. அப்ப என்ன ஆகும், அப்படியே கொஞ்சம் மாறும். எங்க Q by 4 pi r square into AR vector, this unit vector. And the direction solitella, distance of r nu solitella. So with respect to the distance r, I am going to write the unit vector. Okay. We are going to find out the relationship between D vector and E vector. So D vector is electric flux density. E vector is electric field intensity. Okay, see the difference. Now we are going to find the relationship between those two things. That is E vector is nothing but q by 4 pi epsilon naught r into unit vector வரும். D vectorங்கிறது பார்த்தீங்கன்னா q by 4 pi r square into unit vector. Okay, AR vector. Okay, so இது ரெண்டையும் நீ ratio எடுக்கிற. Okay, ratio na that is nothing but dividing to each other. D by E. Okay, D by E எடுக்கிற. So D ஓட value substitute பண்ணு 4 pi r square into A vector தான் உன்னோட D value. இதே E vector க்கு q by 4 pi epsilon naught r square into unit vector. இதுல என்ன வேல்யூ வருது? Epsilon naught மட்டும்தான் மிஞ்சும், மீதி எல்லாம் cancel ஆயிடும். Okay, so epsilon naught alone will be there. So அப்ப you can represent the D vector as E vector into epsilon naught. Okay, this is for free space. Free space now that you will be having that epsilon naught in the electric field intensity. Otherwise, you will be having both epsilon naught and epsilon r. Okay, in case of other field. Okay, so free space number two, you will be having only epsilon naught. Otherwise, there will be a epsilon r also. So generally, you can represent the D vector as epsilon naught into epsilon r E. This simply you can replace the value of epsilon in the place of epsilon naught into epsilon r. Now, small properties for this is given there. That is, the D vector and E vector both will be acting in the same direction. Adhe mari D vector and E vector will be related to each other through the medium of permittivity. Okay, and then the relationship which is derived due to the point charge will be resulting in a the result will be applicable for any charge distribution. Yeah. Then fourth property is the electric field intensity due to any charge configuration is a function of permittivity, while the electric flux density is not. So electric field intensity will depend on the permittivity, but electric flux density will not depend on any permittivity. Okay.